Hi guys, this is lesson 8.7. We're going to learn how to factor special cases like perfect square trinomials and the difference of two squares. Just as a reminder, we're going to go back to our old note-taking system that seemed to work better for learning, which showed up on quizzes and tests. So please, if you don't have your notes ready, pause the video and get them ready. If you don't have your notebook with you, you can put it in regular paper right now and add it to your journal later. Alright, so I do want you to pause on this screen and note these two key concepts. I want to talk about them a little bit too, but please make sure they are in your notes before you go on to the next screen. Alright, the first one is factoring perfect square trinomials. This is talking about if you have a perfect square trinomial, you can take this shortcut in factoring it. Please note, if you ever forget the shortcut, you can use the same methods I've been teaching you all along. Those will still work. This is just a shortcut if you happen to recognize that a trinomial is a perfect square. And I'll talk to you about how to do that on an example. Alright, so that is this area right here. You want to make sure to get this in your notes. Also, later in the lesson we'll be talking about a square minus a square. Remember, difference means subtraction, so the difference of two squares, and the shortcut that we can take there. But again, if you ever forget the shortcuts, you can do it the way that we've learned all along. It will work with every kind of factoring. So pause the screen and write these down. Alright, I'm going to go ahead and start with a simple example, and we're going to talk about factoring a perfect square trinomial. Now, if we did not know this was a perfect square, we would first look for the greatest common factor and then break this into two sets of parentheses. We still need to look at whether there's a greatest common factor or not of each term. So the factors of our first term are 1, x, and x. Our next term has several more factors, but our last term, you'll see, does not have an x. And so if 1 is the greatest factor that's in common between the first and last term, then 1 is our greatest common factor, and we do not need to take out a 1 because that won't change anything. So then what we want to do is, I'm going to rewrite this right here so that way we have it separate from all of this text. Anytime that you happen to notice that this and this are both perfect squares, which in this case they are, x squared is x times x, 36 is 6 times 6. So they're both perfect squares. Anytime you happen to notice that, you want to look at this term right here. If this term is 2 times the square root of the first term, which would be x, and the square root of the next term, which would be 6, then it is a perfect square trinomial. And if we simplify 2 times x times 6, we have 12x. I should have said also, the other thing that we really want to check for before we even do that is that this is positive. Okay, if this is a perfect square, this has to be positive for the trinomial to be a perfect square, because we're either going to have negative 6 times negative 6 or positive 6 times positive 6 to make this positive 36 right here. So that is important. We do need a plus sign there. If we have the plus sign, we have our two perfect squares, then we do this to check the middle term. Alright, so this trinomial does check out as a perfect square. Since it does, we can go ahead and use the formula that we noted in the key concepts. And that is, we can do this, and then we just take the square root of the first term, so the square root of x squared is x. We use this sign right here, right? So minus, And then we do the square root of the last term, which is 6. Alright, if you forget that formula, look at what happens. We have x squared minus 12x plus 36. We go ahead and do our two sets of parentheses, right? And we have x and x. This plus sign tells me that they're going to match. This minus sign tells me they will both be minus. What are two factors of 36 that add up to 12? 6 and 6. Now see how this is the same thing as that? This is just a simpler way of writing it, which if you ever do have two terms that match like that, you should simplify it to this form. Alright, pause the video and go ahead and try the got it's. Alright, for got it 1a, you should have gotten the quantity of x plus 3 squared, and for b, the quantity of x minus 7 squared. If you didn't, go ahead and pause the video and go back and investigate, recheck your notes, and rewatch how I did problem 1. Problem 2 is a little more exciting. We actually get to apply this to real life, which is a lot more meaningful than just a random trinomial. Alright, so we're given that the digital image on a computer are composed of thousands of tiny little pixels that render as squares. And we can see that in this area of the picture here. All these tiny little squares are what produces that frog on that screen for us. Alright, suppose that the area of just one tiny little pixel is 4x squared plus 20x plus 25. And it wants us to say what the length of one side of the pixel is. So that's asking us if we're given an area and we want to find a side, we need to factor. Sorry, I'm dragging my stylus here. Alright, so we have our equation. We first check for greatest common factor, and 4 and 25 have nothing in common as far as factors go. So we cannot take out a GCF. So next we're going to look and see, is this a perfect square? I have a plus sign, I have a perfect square, I have a perfect square. So is the square root of 4x squared, think about what is the square root of 4? It's 2. The square root of x squared is x. And what is the square root of 25? It's 5. If I multiply all of this by 2, will I get the middle term? So let's see, 2 times 5 is 10, and times 2 is 20, times x is 20x. So since I do get this middle term, I have a perfect square. So that means I have something like this. So I just take the square root of the first term, which we already said is 2x. I take the square root of the second term, which we already said is 5, and then this sign goes right there, and I have factored this trinomial. But have I answered the question? The question asks, what is the length of one side of the pixel? So I would say that one side of the pixel is 2x plus 5 units long. Alright, so I would go ahead and put parentheses on these to say units. Alright, pause the video and go ahead and do got it too. Alright, you should have been able to confirm that this was a perfect square trinomial with no greatest common factor, and then just did the square root of the first term, use this sign, and square root of the last term, and squared. And now this is it factored. If I just want the length of one side of the patio, I no longer need to say squared. I don't need both factors anymore. And I would just say units, because we were not given centimeters or anything like that. This next section is my favorite. This is called difference of two squares. That just means a square minus a square. If you want to do it the long way that we have already learned before, we could just go ahead and say that there are 0 x's, right? Would you agree that z squared plus 0x minus 9 is the same thing as z squared minus 9? So if you did this the way that we've been taught before, we would put a z here and a z here. We would have a plus and a minus, and then we'd say what are two factors of 9 that when we add, or of negative 9, that when we add them up we get 0, and that would be 3 and negative 3. And if you look back at the key concept that we noted at the beginning of the lesson, we are given that if we have a square minus a square, to factor it, all we have to do is put the square root of each here, 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 and here, and then have a plus and a minus. Please remember to have the plus come first. Pause the video and do got it 3. Alright, you should have gotten v plus 10, v minus 10, and s plus 4, s minus 4. Alright, let's look at problem 4. Do we have a perfect square minus a perfect square? We do. So we just go ahead and take the square root of the first term, which is 4x, and put it here and here. Square root of the second term, which I just covered up. I think it said 81. If it doesn't, then you can go ahead and fix that. But I think it said 81. So then we have a plus and a minus, and we're done. Go ahead and try got it 4. Pause the video. Alright, you should get 5d plus 8 times 5d minus 8. For question B, it asked could we do it with a plus sign instead of a minus sign? And we couldn't, because if we had two pluses, for example, we'd have a 16d in the middle. If we had two minuses, we'd have a negative 16d in the middle. So this only works with subtraction, so that way when we add the 8 and subtract the 8, we end up with a 0 term in the middle. You've probably been wondering why we haven't had any problems with the greatest common factor yet. Well, I did not want to disappoint you, so we have one here. Notice here 24g squared minus 6 has a greatest common factor. Do you see what it is? If you said 6, you are correct. Now 24g squared divided by 6 is 4g squared. Oops. And 6 divided by 6 is 1. Now, don't think we're finished yet, because look at what's inside those parentheses. We have a perfect square minus a perfect square. And anytime we have that, that means we can go a little further. Alright, so what is the square root of 4g squared? It is 2g. What's the square root of 1? 1. And then we have a plus, and we have a minus, and we're done. Go ahead and pause the video and do got it 5. Okay, these are the answers you should have gotten for got it 5. Go ahead and go back and redo anything you had trouble with. Pause, rewind, do whatever you need to do to make sure that you understand what you're doing here. Then try all 8 of the lesson check problems. I've posted them on here for anybody who might have forgotten to bring their book home. Put everything in your notes and make sure if you have a question, write it down for me right now, so that way you don't forget to ask me in class, and we'll make sure to go over it in class.